Hello my dear students, this is ASHUTOSH. Today we will discuss about Venturimeter. Actually we need a type of instruments by which we can measure the speed of the liquid, flowing liquid. So with the help of manometer we can measure the speed of the flowing liquid, right? How we can measure the speed of the flowing liquid? We can see, and the instrument which is used for that measurement is known as Venturimeter. So let us discuss. Come to next slide. This one, basic working principle of Venturimeter. Actually Venturimeter is a device to measure the flow speed of incompressible liquid. The liquid must be incompressible. It consists of a tube, as we have discussed. We need a device that is known as manometer. Manometer is a type of device by which we can measure the pressure difference across any type of tube, right? So with the help of manometer we can measure the speed of incompressible liquid, flowing incompressible liquid, and that is also known as Venturimeter. So the basic principle of Venturimeter we can derive with the help of, as we all know, that principle of continuity and Bernoulli's principles. We have already discussed these type of two equations. When we are talking about principle of continuity, that means a1 v1 equal to a2 v2. Or in words we can say that the product of area and velocity of any flowing liquid, that will be constant, right? So with the help of principle of continuity we can derive the equation a1 v1 equal to a2 v2. Let's suppose the Venturimeter have two cross section area, one is broad, one is narrow, and the area of the broad is let's suppose capital A, and the area of narrow side, that will be small a, and respective velocity will v1 and v2. Then a1 v1 equal to a2 v2. We can find the expression of v2, that will equal to capital A upon small a into v1, right? This is the first expression by the principle of continuity. Now by the Bernoulli's principle or Bernoulli's equation, we can find another relation when h1 equal to h2, height of first area to the height of second area, or we can say the terminal height of first and second, that will be same. If h1 equal to h2, then by the help of Bernoulli's equation we can also derive second equation, p plus half rho v square plus rho g, that will be constant, and a principle of Bernoulli's. Then p1 plus half rho v1 square equal to p2 plus half rho v2 square. In place of v2 we can use first equation, so put the value of v2 in second equation. Then what we will get? P1 minus P2, that will be equal to half rho v1 square in bracket a upon a to the whole square minus 1. This is the basic principle, or this is the basic equation by using Bernoulli's equation. So while we can conclude that this pressure difference can be measured by this manometer, right? So manometer, why we are using manometer in this Venturimeter? We have to measure the pressure difference, and the device which is used to measure the pressure difference, that is manometer, right? So p1 minus p2 can be easily measured with the help of this manometer, right? So come to next expression. This is the basic diagram of Venturimeter. As we have already discussed, it have two cross sectional area, one is broad and another is narrow, right? If the area of the broad portion is capital A and area of narrow portion, that will be small a, and the velocity will be v1 and v2, and the pressure difference that will create across the U tube, है ना, we can easily see in the diagram there will be pressure difference. Actually U tube, that is monometer, is filled with mercury, and by the seeing the height of that mercury, we can see the pressure difference across this U tube, right? So the difference of pressure that will be that will indicate with the height, we can see the pressure difference across U tube. So that pressure difference will equal to rho gh. P1 minus P2 equal to rho gh, as we have already discussed. But in case of density of that liquid which is inside that U tube, that will be rho m. Rho m is the density of that liquid which is filled inside the U tube, right? So this pressure difference will equal to rho m gh, that will also equal to half rho v1 square, and that will be the same expression which we have discussed in equation number 3. So we can easily calculate the value of this velocity which will be across first terminal, that will be v1 equal to square root of 2 rho m g h upon rho into a upon a to the whole square minus 1 to the whole square of minus 1 by 2. This is the final expression of velocity which we want to measure with the help of this Venturimeter. So basically, dear students, Venturimeter is used to measure the speed of flowing water or flowing liquid, है ना, with the help of that manometer. That while we are talking about application of Venturimeter, then it can be used any type of devices where we can increase the area, we can increase the pressure so that, or decrease the pressure so that the flow of liquid may be controlled, है ना, like while we are using in spray gun. You can see in this diagram, this is the diagram of a spray gun. In a spray gun, while the cylinder is going upward or downward, then the pressure will increase or decrease. When the pressure will increase or decrease, the velocity of the that liquid, that fluid will vary. So this is the basic principle in all the devices, in maximum devices. While we can increase or decrease the pressure, corresponding velocity can be increases or decreases, right? We can see another important explanation through this Venturimeter, that will be blood flow and heart attack. This is another important point. We can conclude with the help of this with the help of Bernoulli's principle. We can see that whenever in our body, if the pressure increases, then velocity decreases. If the velocity increases, then pressure decreases, right? So this principle can be explained while heart attack happen in human body, right? So with the help of Bernoulli's principle, we can see, while we know that accumulation of accumulation of Planck means, while the our arteries became blockage, there will be blockage between human arteries. Then what happen? Then then heart will apply, heart demand high pressure, heart demand high speed of blood. Then what happen? Due to high speed of the blood, pressure will decreases. If pressure will decreases, then that arteries will coincide, है ना, collapse. If arteries will collapse, then again blood increases speed, again arteries will collapse. That's why it happens, and the result, this may result as a heart attack, right? So we can explain, or we can conclude that whenever the speed of the liquid is higher, then pressure will decreases, then the arteries will become collapsed. Arteries, the wall of that arteries will coincide, constricted, है ना, so it creates heart attack. We can solve some type of examples with the help of these equations which we have derived earlier. Next one, dynamic lift. Dynamic lift, basically this is the type of force which we can apply in various applications, like in cricket, like in another outdoor games like tennis, baseball, golf. We can move the ball. While the ball moving forward, then by moving we can just turn on that ball. So moving ball with spin, है ना, that can be explained with the help of this dynamic lift, which we can discuss in next video. So this is all about Venturimeter. We can see this type of phenomena will happen while we are discussing about this dynamic lift, right?